For over a century, people have wondered, could the Titanic ever rise again? Imagine, about 2 miles down in the North Atlantic, the great ship resting in silence, split apart on the sea floor. At first glance, it seems like only a question of engineering, a problem waiting for a practical solution. We'll quietly look at why law and respect, deep-sea decay and sheer cost keep the ship where it lies. Let's take a quiet look at how, across time, people have still tried to imagine ways of bringing her back. In the years just after the disaster, the idea of raising the Titanic began to surface almost immediately. By 1912, families of first-class passengers such as John Jacob Astor, Benjamin Guggenheim, and George Widener were quietly exploring whether salvage might be possible. Their interest was not only in the grandeur of the ship itself, but also in the hope of retrieving belongings or keepsakes tied to those they had lost. They reached out to the Merritt and Chapman Derrick and Wrecking Company, one of the most capable firms of the time, to ask if recovery was within reach. The answer was firm. With the technology then available, the plan was impossible. Even so, the raw grief of the era sparked ambitious ideas. Some thought the wreck could be pulled to the surface through sheer mechanical force. In 1914, a proposal appeared describing the use of massive electromagnets lowered from above, devices that would attach themselves to Titanic's steel hull. Winches mounted on surface ships would then pull, as if tugging the vessel straight out of the seabed. While simple in theory, the plan belonged more to science fiction than real engineering. The magnets did not exist at the scale required, and the immense pressure of the deep ocean was completely underestimated. Alongside such engineering dreams, some desperate suggestions briefly appeared. A few writers speculated about blasting away surrounding seabed with explosives to release the ship. These thoughts were short-lived and never acted upon, but they reveal the level of longing people felt in those early years, and how imagination often leapt ahead of practicality. Other schemes took a different direction, embracing the principle of buoyancy rather than brute strength. If the ship could not be pulled, perhaps it could be floated. Engineers and amateur inventors alike drew up plans to send down huge containers filled with air or gas, fastening them along Titanic's hull until the ship itself rose like a cork through water. The difficulty was staggering. Hundreds of such tanks would have been required, each lowered by cable through nearly 2 miles of shifting currents. The sheer weight and logistics were far beyond what was possible in an age without modern submersibles or deep-sea robotics. By the mid-20th century, the more imaginative ideas for raising Titanic became even more elaborate, though the forces at play nearly 4 kilometers down told a different story. At that depth, every inch of the wreck lies under about 6,000 pounds of pressure, like a small car pressing down on a single square inch. This reality framed both the dreams that continued to appear and the reasons they faded. One of the most famous suggestions was to fill the ship with millions of ping-pong balls. Since they float, the thinking went, they could lift Titanic back to the surface. Yet under such immense pressure, any ordinary plastic ball would simply implode long before reaching the wreck. Others imagined a stranger version of buoyancy by packing the ship with Vaseline. While technically lighter than water, the vision ignored the impossibility of lowering enormous barrels to nearly 13,000 feet and the fact that cold and pressure would alter the material itself. Some proposals reached for more creative approaches. Designers pictured Titanic packed with pressure-resistant glass spheres, each capable of holding air and creating lift. But the scale was staggering. Millions of units had to be manufactured, shipped, and placed. By the time cost estimates appeared, they approached hundreds of millions of dollars, even in mid-century values, rendering the concept little more than a sketch on paper. One of the boldest schemes suggested encasing the ship in ice by pouring liquid nitrogen over its hull, the idea being that a frozen block would float upward as an artificial iceberg. Engineers at the time calculated that 500,000 tons of liquid nitrogen would be required, along with an entire offshore liquefaction plant to supply it. The idea may have sounded poetic, but it was utterly beyond reach. Looking back, these plans may sound whimsical, bordering on fantasy. Yet they also speak to the emotional need of people to imagine action, to believe that something could still be done for a ship that had come to symbolize so much loss. In that way, the ideas say as much about grief and memory as they do about engineering. The true turning point came in September 1985, when Robert Ballard's team located Titanic using the deep-sea vehicle Argo. A single boiler marked the find, and what followed ended decades of speculation. Cameras revealed a wreck ripped in two, its stern collapsed into tangled steel, its bow driven deep into the seabed. Between them stretched a debris field covering nearly 3 miles. The vision of a vessel lying intact, waiting to be lifted whole, was gone forever. What human eyes had once pictured as a preserved ship turned out instead to be a fragile grave. The steel was already breaking down into rust, the decks collapsing in places, the structure too delicate to ever move without destruction. Which brings us to a quieter question. If attempts to raise the ship proved impossible, what would it mean even today to imagine fully restoring Titanic? If someone were to announce in 2025 that Titanic could finally be raised, the idea might sound bold at first. But you know, the closer you look at the obstacles, the clearer it becomes that a genuine restoration is just not possible. 4 barriers stand out: the ship's structural fragility, its ongoing decay, its legal and memorial protection, and, well, the staggering cost of any attempt. The first challenge is the wreck's condition. Titanic's steel is no longer solid in the way people imagine. A newly identified bacterium, named Halomonas titanicae, consumes the iron and leaves behind rusticles, fragile, icicle-like growths that crumble when touched. These structures have actually replaced large portions of the ship's material strength. What once was steel plate is now brittle and hollow, making the wreck far too unstable to lift or even secure with equipment. These changes are not only invisible processes, but also clearly visible over time. One of the starkest examples is Captain Smith's quarters. In 1996, cameras still showed a recognizable bathtub, furnishings, and parts of the deckhouse around it. By 2019, those features were gone, the deck collapsing into heaps of twisted metal. What held its form one decade can quietly vanish in the next. The whole wreck is following the same pattern of collapse, leaving little to preserve. Even where recovery has been attempted, the amount of effort required underscores how impractical restoring the entire ship would be. In 1998, a 15-ton section of Titanic's hull, known as the Big Piece, was raised. Special cranes and precise planning made the lift possible, but that was only the beginning. Conservators then spent 20 months bathing the metal in sodium carbonate solution to flush out salts and stabilize what remained. That was for a single piece of wall. Scaling such treatment up to an entire ocean liner makes the idea of full recovery feel less like restoration and more like an impossibility. Then comes the legal and ethical boundary. The wreck is formally protected as a maritime memorial, recognized by both the United States and Britain under an international agreement. Article 4, Section 1 affirms that salvage for simple recovery is prohibited, with preservation given priority. NOAA has supported this position, treating the site with the respect due to a grave. RMS Titanic Incorporated does hold rights to recover artifacts, but even modest proposals have caused public concern. In 2020, when the company suggested retrieving Titanic's wireless set, the idea was condemned by many who saw it as trespassing into a resting place. And finally, there is the matter of cost. When the Costa Concordia cruise ship was salvaged off Italy after its sinking in 2012, it was far easier to access shallow water, upright position, and modern ship design. Even then, the operation cost around $800 million. Titanic lies 13,000 feet below the Atlantic, in pieces, and far less stable. Any attempt to recover it would be many times more complicated, likely costing billions. Taken together, these barriers, fragility, collapse, law, and cost, explain why 2025 cannot see a true restoration. The ship will never return whole to the surface. But its lasting presence does not depend on being lifted skyward. It rests instead in a different form of remembrance that endures quietly in the present. In thinking about what the future holds, it helps to remember the difference between preserving and restoring. The ship itself cannot be saved, but artifacts can. We saw this with the big piece, carefully lifted and stabilized over months of conservation work, or in contrast with Captain Smith's cabin, where visible rooms seen in the 1990s had fully collapsed by 2019. These moments remind us what may be preserved and what must be left undisturbed. Perhaps the truest restoration lies in memory, keeping stories and artifacts alive with quiet respect. If you found this calming, consider subscribing for more gentle looks at curious histories.